So hello and welcome everyone. So in this video, I'm going to share top 5 questions on queues which you can practice on your own, and these questions will help you to understand different algorithms. You will be able to learn where queue data structure is very much used, and it will be helpful to you in interviews as well. So I'll be sharing the hints of every question, but I would like everyone to try the solution or the approach on your own, and I want everyone to share your solution in the comment section below. So let's start. So the first question is generate binary numbers. So in this question, basically what you have to do, you will be given the value of n and you have to generate all the binary numbers from 1 to n. So let's understand with the help of a test case. So over here, in the first test case, it is given that the value of n is equal to 2. So all the binary numbers from 1 to 2, and this is what the binary numbers from 1 to 2 contain. So in the output, you can observe this is what is printed in the output. So in the test case number 2, for n is equal to 5, you have to write down all the binary numbers from 1 to 5. So that would be 1, 2, and this is going to be 3, and this is going to be 4, and this is going to be 5. If n was equal to 6, then you have to generate all the binary numbers. I hope you understood the basic idea of the question, but over here, so now in order to generate the binary numbers with the help of queue, the technique to generate binary numbers with the help of the queue is kind of interesting. Let me give you the observation and you can try the approach on your own. So you can observe, let's say if I'm taking the first binary number 1, then what I'll be doing, I'll be appending a 0 and a 1 to this 1. So that would be 1 0 and 1 1. So now let's say if I want to generate next binary number. So what I'll be doing, I'll be taking this 2 and I'll be appending a 1 and a 0 to it. So first of all, appending a 0, it will give me 100, and appending a 1 will give me 101. So now let's say if I want to generate the next pair of binary numbers, I can take this 1 1 and append a 0, that would give me 1 1 0, and appending a 1, that would give me 1 1 1. You can observe this is the first binary number 1, this is 2, and this is 3, and you can observe that this is 4 and this is 5. So in this manner, you can utilize the queue data structure to generate all the binary numbers. Try the solution on your own. So the next question is you have to implement the queue with the help of stack data structure. For this question, you need to understand what is a stack data structure and you should know the basic operations which you can apply on a stack data structure. So the prerequisite for this question is stack. So what you have to do, you will be given all the operations, NQ operation, DQ operation, which are provided by the queue data structure, but you have to utilize the stack data structure and implement all these operations. So over here, we know that if you have studied stack data structure, then stack is a last in first out. That means all the operations can be applied from a single end only. While if I talk about the queue data structure, then queue has both the ends open, and depending upon the type of the queue, you can insert or remove the element from either of the end. So that would be an interesting thing. You have to understand how you can utilize the stack data structure. You have to understand how to apply efficient algorithm, that how many stacks are required to implement the queue, and so on and so forth. So try to implement the queue data structure with the help of a stack. So this is being asked in interviews as well. So now let's take a look at the third question. So third question is nothing but the breadth first search algorithm. So if you are working with graph data structure, then you might be aware about traversal techniques, right? So basically, entire breadth first search algorithm is completely dependent upon the queue data structure. So before moving on to the graph topic, you need to understand what is a queue data structure. You need to understand how to utilize the queue. So over here, here is our breadth first search algorithm. So in this question, you will be given the details about the graph. You will be given adjacency list, and what you have to do, you have to traverse the graph with the help of the breadth first search algorithm. And in the breadth first search algorithm, you need to use the queue data structure. So let me give you a rough idea of how that algorithm works. So basically, in this test case, I have taken a directed graph, and now I have to apply the breadth first search algorithm on this graph. So in this test case, let's apply the breadth first search algorithm. So breadth first search algorithm works on the adjacent nodes of your current node. So currently, if I'm standing at this node number 0, if I've started my BFS with node number 0, then 0 will be printed, and inside the queue, all of its adjacent neighbors which are not visited will be inserted. So 1 will be inserted, 3 will be inserted, and 4 will be inserted. So first of all, 1, 3, and 4 has been inserted. Now you have to remove one element from the queue. So I'm removing 1, and now again doing the same thing, that is inserting all the adjacent nodes of 1 which are not visited inside your queue data structure. So that means I can see no neighbors of 1 which are not visited. So one will be printed in the output. And now again what I need to do, I can again I need to do the same thing with the 3, remove from the queue and append or insert all the adjacent nodes of 3 in your queue. So I can see one of the node 2 is not visited and it is not present inside my queue, so I'll be inserting 2. So now doing the same thing with the next element, that is 4, remove it from the queue data structure and insert all its adjacent nodes. But over here you can observe no adjacent nodes are present. So in this manner, until and unless nothing is left inside your queue, you have to keep on doing this process, and at the end you will be removing 2, and after 2 nothing will be inserted. So in this manner the breadth first search algorithm works. So try to understand this algorithm and try to implement it with the help of queue data structure. So now let's see the next question of this list. So the next question is circular tour. So let's understand the problem statement. Suppose there is a circle and there are n petrol pumps on that circle. So basically you will be given two arrays in the input, one denoting the amount of petrol and the other denoting the distance between two petrol pumps. So basically what you have to do, you have to find a starting point where the truck can start to get through the complete circle without exhausting its petrol in between. So basically you have to make a circular tour on this map, and you have to choose a starting point in such a way that a circular tour can be done for the entire circle. So let's understand with the help of a test case. So over here I have taken the test case which is given to us in the input. So basically let's write down the details of the first array, that is petrol array. So this is the array given to us in the input and these are the index 0, 1, 2 and 3. Let's say if I start the traversal from the index number 0. So I know currently I don't have any amount of petrol with me. And what is the distance in order to reach the next petrol pump? The distance required which I need to traverse is given to me as 6 units. So I need to traverse 6 unit of distance. So basically what amount of petrol will I get from the 0th index? I'll be getting 4 units of petrol. So now currently I have 4 units of petrol, and each unit of distance will cover 1 unit of petrol. So basically in order to cover 1 unit of distance, you are required 1 unit of petrol. So the distance is 6 and currently you have only 4 units of petrol. So obviously you cannot reach the station present at the index number 1. So this is not going to be your starting point. So let's start with the index number 1. So currently you don't have any petrol. So from this petrol pump I'll be getting 6 unit of petrol. And what is the distance that I need to cover? The distance that I need to cover to reach the second index is 5 units. So basically I can observe that the amount of distance is lesser than the amount of petrol I have. So I can obviously jump to the index number 2, and currently after jumping to index number 1 I'll be left with 1 unit of petrol. From the index number 2 I'll get 7 unit of petrol, so currently I'll be having 8 unit of petrol, and now the distance I need to cover is 3. So basically if I cover this distance I will be left with 5 units of petrol. So now currently I have 5 units of petrol, and from this petrol pump I'll be getting 4 units, and that becomes 9 unit of petrol. So as I mentioned that this map is circular. So basically from this last index you will be capable of going to the index number 0, and the distance required is 5 unit of distance is what I need to cover. So currently I have 9 units of petrol and the distance I need to cover is 5. So obviously I can traverse from index 3 to index 0, and the amount of petrol I'll be using is only 5. So currently I'll be left with 4 units, and currently I'm standing at the index number 0. Now from index number 0 I'll be getting 4 units of petrol. So currently I'll be having 8 units, and from this index 0 to go to index number 1, in order to complete the circular tour I need to traverse 6 units. So basically this distance is lesser than the amount of petrol which I have. So in the output 1 will be printed because I started the tour from the index number 1. So in this way you have to solve this question. So now the hint is that in order to solve this question, actually you can use a queue data structure as well. So the basic brute force approach can be done with the help of nested loop, but that will be having higher time complexity compared to the queue implementation of that algorithm. So try to think how you can optimize the basic brute force approach and then come up with a solution for this one. So now let's take a look at the next question. The last question is maximum of all subarrays of size k. This question is very important from interview perspective. So let's understand what the question says. So in the question, you will be given an array of size n and you will be given an integer k. So what you have to do, basically you have to find out for each and every contiguous subarray of size k, you have to find out which is the maximum element. Let's understand with the help of a test case to get a clear understanding. So currently I have taken the input test case which contains this many elements inside an array and the value of k given to us is equal to 3. So now over here, for each and every subarray of size k, that is size 3, I need to find out which is the maximum element in that subarray. So this is going to be my first subarray and the maximum is 3, hence in the output 3 will be printed. So now sliding this forward, and this is my subarray, and in this subarray also I can see the maximum is 3, hence 3 will be printed in the output. So now let's move forward and see the next subarray. So the next subarray will contain 3, 1 and 4, and the maximum over here comes out to be 4. So the next subarray is containing 1, 4 and 5, and maximum from 1, 4, 5 is equal to 5, and in the output we can observe 5 has been printed. And the next subarray is containing 4, 5, 2, and the maximum is 5, and so on. You have to traverse the entire array, and for each subarray of size k, get the maximum element. So basically, this question can also be done in a brute force manner with the help of nested loop. You can optimize it a little bit, but over here, if you will think how you can utilize a queue data structure with the most space efficiency, then it is going to be a very trickier approach. So try to think how you can utilize the queue data structure to solve this question, and you will find out an interesting way to look at the queue data structure. Although nothing will be prioritized, but if you store the elements in some specific manner in a queue or a stack, you can utilize them as a prioritized stack or prioritized queue as well. So in order to solve this question, you can use a basic brute force approach, that is using nested loop, and you will be able to figure out maximum of all subarrays of size k. But over here, in order to optimize it, you need to utilize the queue data structure. So try to think how you can use the queue data structure and get the most efficient solution from this one. So that was it for today's video. I hope you really enjoyed the video. And if you find this video to be informative, then do not forget to hit the like button and share it with your friends. And do not forget to share the solution in the comment section below. Thank you.